Here you go, Liz.
Thanks.
You're welcome. Say, Liz, I understand you're a pilot.
That's right. I'm also a flight instructor.
Well, now that sounds interesting. Well, what exactly does an instructor do?
Well,
As flight instructors, we have all heard this question at one time or another. And it's not an easy question to answer. Stated simply, we teach people how to fly. At first, these images may come to mind. On the other hand, there are a lot of CFI activities that go beyond the Learn to Fly category. While most people associate training activity with students seeking initial certification, there are a wide variety of specialized instructional services that we can also provide. These services may include regional and local checkouts, instructing in aircraft with conventional gear, checkouts in high-performance airplanes, multi-engine checkouts, and high-altitude training. This presentation introduces some general guidelines that apply to most checkouts, but also focuses on some additional factors which are unique to each type of training. Developing an outline for specialized instruction will help you provide comprehensive checkouts. One way to do this is to expand on a basic lesson plan format, or for transitions to other aircraft, the FAA provides a sample training plan in Advisory Circular 61.98A. A transition syllabus prepared by the General Aviation Manufacturers Association, or GAMA, is also referenced in Advisory Circular 61.103. But before we take off, we need to stop and address a number of important factors relating to the training program for a specific checkout. Evaluating our own ability to provide comprehensive instruction is one consideration. Before providing specialized training, we should ask ourselves some specific questions. Am I qualified by regulation to provide this type of instruction? FAR 61.195 describes applicable limitations regarding instruction. Experience is another important issue. Do I possess the experience necessary to provide a comprehensive checkout in this airplane or in this region? We should be very familiar with the make and model of the airplane and its flying characteristics. Can we accurately explain specific systems and operating procedures to the pilot? How recently have I flown the aircraft, reviewed the information, operated in the area? If we have the experience but have not put it to use lately, we may want to review the material before we teach it to someone else. The next step is to obtain some specific information from the pilot to help tailor the training to the individual. Find out about the pilot's flying background, including the certificates and ratings held, number of hours logged, experience in different airplanes, or operations at specific airports. If the pilot has not received any training recently, a review of basic procedures or subjects may be necessary before you introduce new material. Finally, the pilot's intention regarding the checkout is an important consideration. Will the pilot be flying frequently, in the local area or cross-country? Is the pilot considering any additional training? It is also important to know if the pilot is a flight instructor intending to provide instruction in the local area. Using the information provided by the pilot, determine if specific training or endorsements are required by regulation for the pilot to act as PIC of the airplane. It is important to brief the pilot on materials to review prior to the checkout, such as the pilot's operating handbook or information about the local flying region. This initial preparation will make the training more productive and enable you to focus on subject areas most valuable to the pilot. For an airplane transition, suggest that the pilot take time to sit in the cockpit and become familiar with the location of the instruments and equipment. In preparation for the flight portion of the checkout, you will need to determine what operations to cover and if regulations require proficiency in particular maneuvers. For example, if the pilot does not hold a category and class rating for the airplane and intends to solo, FAR 61.31 states that the pilot must have received flight instruction in the operations required for the first solo. The pilot should be aware of your expectations and the time it will take to complete the checkout. An initial evaluation flight may help in accurately estimating the hours that will be needed. To evaluate the pilot's performance during the checkout, consider using the standards listed in the PTS that apply to the certificates and ratings the pilot holds. These basic guidelines for preparing your instruction apply to most specialized services. Now let's look at types of specific checkouts and discuss the subject areas unique to each. A regional or local checkout is a service you can provide to a pilot who moves to a different area or will be operating out of an unfamiliar airport for an extended period of time. Flying environments vary greatly due to terrain, weather patterns, airspace, and traffic considerations. In addition to familiarizing the pilot with the local airport or region, there are other factors to consider in providing this type of checkout. For example, more than one goal can be accomplished during a local or regional checkout. You can suggest options to the pilot which will make the checkout more productive. A biennial flight review or airplane transition training may be combined with this checkout, or a complete mountain checkout may be appropriate for the area. The pilot may want to begin training for an additional rating or feel the need to review specific subjects or maneuvers. In addition, it may be necessary to point out local practice areas or the availability of practice instrument approaches if the pilot is a flight instructor. In preparation for the flight, it is important to explain how the area's climate and elevation will affect the airplane's performance. The pilot should calculate performance for the airplane based on local conditions. This is necessary regardless of the area. Many times the focus is placed on the decrease of performance when training pilots transitioning from low elevation to high elevation airports. Don't forget that an increase in performance at lower elevations or cooler temperatures may also be unfamiliar to pilots if they are accustomed to flying at higher elevations. Calculating takeoff and landing distances may help reassure the pilot that what appears to be a very short runway is sufficient in length. Also, the pilot may not be aware of the increase in climb performance and have a tendency to overshoot the desired level-off altitude. You can also point out that a richer mixture may be required and fuel burn will increase with flight at lower altitudes. Regardless of the pilot's previous experience, it is essential to review the performance charts in the pilot's operating handbook. If the pilot has been operating at one airport for an extended period, it may have been some time since the pilot analyzed performance data. Of course, the pilot will need to become familiar with the terrain features and airspace in the area. While studying the sectional for the region, it may be appropriate to review the symbols and definitions on the chart. Operating requirements for specific classes of airspace in the area may also need to be covered. If the pilot is instrument rated, a discussion of the en route, arrival, approach, and departure procedures for the area is recommended. To help the pilot feel more comfortable in the new surroundings, take some time to point out specific features of the airport, such as maintenance facilities, where to purchase fuel, and the location of wind indicators on the field. During the flight portion of the checkout, you can familiarize the pilot with local operating procedures and include any additional training as necessary. In addition to the regional or local checkout, a checkout in a specific aircraft is another useful instructional service. As pilots gain experience, the opportunity to transition to new and unique airplane types provides an exciting challenge. If you do not have experience in a particular airplane, you may need to receive a complete aircraft checkout yourself prior to checking someone else out. This will help in becoming thoroughly familiar with the aircraft's systems, limitations, and specific operating characteristics, and better prepare you to provide comprehensive training. The transition to a conventional gear or tailwheel aircraft is a good example of a situation where such a checkout would be required. Gaining experience in conventional gear airplanes enhances your qualifications and expands your instructing opportunities. Because of the unique operating characteristics of tailwheel aircraft, a specific logbook endorsement to act as PIC in a tailwheel airplane is required by FAR 61.31. Although only one logbook endorsement is required, a checkout for each make and model of tailwheel is recommended due to differences in operating characteristics for individual aircraft types. For example, familiar equipment, such as an electrical system, may not exist in older aircraft. Seldom used procedures such as hand propping may have to be reviewed. Also, many tailwheel aircraft lack gyroscopic attitude and heading indicators or radio equipment. Another change may be in the aircraft controls. A stick may be used instead of the more familiar yoke configuration. During the checkout, you should note any characteristics that may affect how you will instruct in the aircraft. For example, in airplanes equipped with tandem seating, there may be reduced visibility from the rear seat, and communications between you and the pilot may be difficult due to high noise levels. In addition, there may be incomplete instrumentation or aircraft controls for the rear seat. Because the regulations require competency in normal and crosswind takeoffs and landings, wheel landings, and go-around procedures, these operations should be the focus of the tailwheel checkout. Mastering takeoffs and landings requires understanding of several unique features of the tailwheel airplane. For example, in gusty or crosswind conditions, the tailwheel airplane has an increased tendency to weather vane into the wind in comparison with nosewheel airplanes. This occurs due to the greater surface area behind the main gear. One consideration during takeoff is the tail lifting off the runway first. If the tail is raised too quickly, the airplane will react as if a force is exerted on the rotating propeller, and gyroscopic precession will cause a pronounced left-turning tendency. During the landing, it is important that the elevator control is eased fully back to hold the tail wheel on the ground. If the tail wheel is not held on the ground during touchdown, the airplane may become airborne again. This occurs due to increased lift produced by the higher angle of attack as the tail is lowered to the runway. Another unique characteristic of tailwheel aircraft is the location of the center of gravity behind the main wheels. This feature increases the difficulty in maintaining directional control, especially in the after-landing roll. The CG location creates a tendency for the airplane to swerve further and further out of runway alignment once it is displaced. If positive directional control is not maintained with the rudder, a ground loop may be the result. Tailwheel training also introduces new procedures such as the wheel landing used in strong or gusty winds. This type of landing increases controllability by allowing the airplane to touch down at a higher airspeed and a lower angle of attack. In addition to becoming familiar with a different aircraft, a tailwheel checkout requires learning new techniques and provides an opportunity to increase flying skills. Having experience in conventional gear aircraft enables you to provide this specialized service to other pilots. As instructors, we can understand the importance of possessing sufficient experience before we are qualified to give safe and comprehensive instruction in a specific airplane. With that in mind, let's take a look at some additional opportunities for aircraft checkouts. The high-performance checkout is one more service you can furnish that will increase a pilot's knowledge, skills, and experience. FAR 61.31 defines high performance as an airplane that has more than 200 horsepower or that has retractable landing gear, flaps, and a controllable propeller. An endorsement is required to act as PIC of an airplane that meets either of these specifications or both. For example, if the pilot receives a checkout in an airplane that has retractable landing gear but does not have over 200 horsepower, a general endorsement stating competency in high-performance airplanes is provided. A second endorsement is not required by the regulation if the pilot then chooses to act as PIC of an airplane that has over 200 horsepower. The reverse is also true. However, it is important to explain to pilots that checkouts in both types of airplanes are highly recommended to ensure comprehensive knowledge of aircraft systems and safe operations. Procedures involving new and increasingly complex systems may be difficult at first for the pilot transitioning to a high-performance airplane. You can help to make the transition easier by discussing the new systems completely. The operation of the constant speed propeller control is usually emphasized during a high-performance checkout, but many pilots fail to fully understand how the system actually works to control RPM. You can explain that propeller designs vary in different aircraft. It is important that pilots have knowledge regarding the principles of constant speed propellers and should review the pilot's operating handbook for the aircraft. For example, most constant speed propellers in light aircraft maintain a preset blade angle by use of a governor. The governor either meters oil pressure to or allows oil to drain from the propeller cylinder to maintain the proper blade angle for constant speed operation. In certain propeller designs, an addition of oil pressure directed to the propeller piston increases the blade angle and decreases RPM. A complete loss of oil pressure in the prop hub system causes the blades to move to low pitch, resulting in high RPM. This provides the benefit of having maximum power available as long as the engine is running. In other systems, the opposite is true, and a complete loss of oil pressure in the propeller hub will create a low RPM situation. This system is valuable in multi-engine airplanes and allows feathering of the propeller when an engine loss occurs. The pilot should also understand the relationship between manifold pressure and RPM and know how to determine proper power combinations. Retractable landing gear introduces a new set of operating procedures, and learning how the system works will help the pilot understand gear operating limitations. The retraction or extension of the landing gear may be actuated electrically or hydraulically. Some systems combine electric and hydraulic components. After the pilot has studied the pilot's operating handbook, you can reinforce understanding with oral questioning. For example, if the gear is hydraulically actuated and a loss of hydraulic fluid occurs, what is the first indication of a problem? What position will the gear be in if all the fluid is lost? Will it stay retracted? Partially extend? Extend fully under its own weight? Gear warning indicators are not standardized. Some systems have indications for a retracted position, while others indicate when the gear is in transition. A complete understanding of how the manual extension system operates is also necessary. In addition to introducing unfamiliar equipment, a comprehensive review of all the systems in the airplane is appropriate if the pilot lacks basic systems knowledge. Be aware that the pilot may have difficulty adjusting to the faster speeds and increased performance of the airplane. The effects of power or configuration changes may seem exaggerated at first. Learning new procedures and operating complex systems increases the workload and may cause the pilot to feel rushed or behind the airplane. The use of checklists while thinking and planning ahead will make the transition easier. A good ground discussion of the systems and operating procedures prior to the flight will also smooth the pilot's transition. The next step for pilots who have acquired extensive experience in high-performance singles may be a multi-engine rating. In other cases, pilots who are multi-engine rated but have not flown a twin recently or wish to transition to a different make and model may require a full multi-engine checkout. The addition of a multi-engine class rating to a pilot's certificate is covered by FAR 61.63. It requires instruction in a multi-engine airplane in operations appropriate to the pilot certificate held. The operations to be covered are found in the appropriate practical test standards. At the completion of training, you must provide a logbook endorsement certifying the pilot's competency. According to FAR 61.195, You must hold a multi-engine class rating on your pilot and flight instructor certificate, and have at least 5 hours of experience as pilot in command in the make and model of multi-engine airplane before providing this instruction. The multi-engine checkout may include a review of the pilot's general knowledge of systems and aerodynamics, but many of the subjects to cover will be specific to multi-engine airplanes. For example, the pilot will need to understand the meaning of several V speeds, such as VYSE and VMC. Performance data, including accelerate, stop, and accelerate go distances, and systems unique to the airplane, can be discussed using the pilot's operating handbook as a guide. And of course, engine out characteristics and procedures will need to be covered extensively. Prior to the flight portion of a multi-engine checkout, the pilot will benefit from an extensive discussion of the factors affecting directional control and engine out performance. You can begin this discussion by defining VMC and pointing out that the published VMC for an airplane occurs only under a specific set of conditions. The pilot needs detailed knowledge of the many variables that will affect controllability in an engine-out situation. Explain that controllability is not the only concern when an engine quits. Climb performance is drastically reduced in an engine-out situation. Point out that an airplane can lose 80% or more of its performance after an engine loss. For example, if a particular light twin climbs at 1,860 feet per minute with both engines operating, it may climb at only 190 feet per minute on one engine. The loss of performance in this case is close to 90%. By examining various aircraft configurations under specific conditions, you can explain to the pilot how each factor affects controllability and performance after an engine loss. One way to begin your discussion is to examine the factors listed in aircraft certification standards under FAR 23.149. The published VMC may not exceed 1.2 times the stall speed at maximum takeoff weight with the maximum available takeoff power or thrust on the engines. The most unfavorable center of gravity. The airplane trimmed for takeoff. The maximum sea level takeoff weight or lesser weight necessary to show VMC. The airplane in the most critical takeoff configuration with the propeller controls in the takeoff position and landing gear retracted. And the airplane airborne and ground effect negligible. Manufacturers may also establish up to 5 degrees of bank to determine VMC. The 5-degree bank is a good example to start with. You can explain the characteristics of the airplane without the bank to help the pilot understand the importance of establishing the bank after an engine failure. If the pilot maintains directional control with the rudder but does not establish the bank, the airplane will be in a side slip. By attaching a yaw string to the airplane, you can provide a vivid illustration of this fact to the pilot in flight. This side slip condition will add to the problem of controllability by causing the relative wind to push against the left side of the vertical stabilizer and fuselage, which will increase the yaw toward the dead engine. The side slip also decreases the rudder effectiveness by preventing some of the relative wind from reaching the rudder. And the airflow that does reach the rudder contacts the control surface at a smaller angle. Aside from increasing the actual VMC of the airplane, a side slip also increases drag, which will result in reduced performance. By establishing the precise amount of bank to create a zero side slip condition, the pilot will increase performance and controllability and decrease actual VMC. Less than a 5-degree bank may provide the best controllability and performance. You may recommend that the pilot initially establish a 5-degree bank and then reduce the bank slightly to determine if a smaller bank angle will have more positive results in performance. In addition to factors listed in the certification regulation, conditions to include in your discussion are the effects of density altitude, airspeed, extension of flaps, and benefits of feathering the propeller. One of the important goals of multi-engine training is for the pilot to obtain a complete knowledge of how specific factors affect controllability and performance in engine-out situations. Becoming proficient in high-performance single-engine and multi-engine airplanes also allows a pilot to operate at increasingly higher altitudes. Training in high-altitude flight is another opportunity for providing specialized instructional services. FAR 61.31 requires specific ground and flight training for a pilot to act as PIC of a pressurized airplane that has a service ceiling or maximum operating altitude, whichever is lower, above 25,000 feet MSL. A logbook endorsement certifying satisfactory completion of the training is also required. This training may not be mandatory for pilots who have specific qualifications that are outlined in this regulation. This also means that to provide the required high-altitude flight instruction to a pilot, you need to meet the requirements of this regulation as well. The regulation lists specific topics that must be covered during ground training, such as high-altitude aerodynamics, high-altitude meteorology, physiology of flight at high altitudes, including hypoxia and other high-altitude sicknesses, use of supplemental oxygen, time of useful consciousness, and knowledge of decompression. In addition, the pilot must receive flight training in an airplane or simulator as described by the regulation. This training includes cruise flight operations above 25,000 feet MSL, emergency procedures associated with rapid decompression, and emergency descents. Advisory Circular 61.107 provides an outline and a textual description of relevant subject areas to help you prepare for high-altitude instruction. The FAA actually recommends this training for all pilots who operate at altitudes above 10,000 feet MSL. To generate interest in high-altitude training, you can suggest that the pilot attend a physiological training program to learn more about the problems associated with reduced atmospheric pressure at high flight altitudes. These programs include a high-altitude flight in an altitude chamber where pilots can learn to recognize the onset of hypoxia by understanding their individual reactions to it. Applications for this training can be obtained from your local Flight Standards District office. If you have not experienced this physiological training yourself, participation in this type of program will greatly increase your instructional knowledge. To introduce high-altitude flying, you can expand upon the pilot's general background knowledge of aerodynamics, meteorology, and physiology. Some topics that you present may be new to the pilot. Pressurization is one subject that may be unfamiliar to a pilot seeking a high-altitude checkout. It is important for the pilot to understand how the specific pressurization system and oxygen equipment in the airplane operates. For example, in most pressurized light twins and singles, pressurization is supplied to the cabin from the turbocharger's compressor or from an engine-driven pneumatic pump. The cabin altitude is manually selected and can be monitored by reference to a gauge which indicates the pressure difference between the cabin and ambient altitudes. Each aircraft has a maximum differential between cabin and ambient altitudes that the pressurized section of the aircraft can support. Decompression can occur due to a system malfunction or results from structural damage to the aircraft. Due to the rapid drop in temperature and the change in relative humidity, fog will often form during a decompression. The human body will also be affected. A sudden low pressure outside the lungs will cause air to escape through the nose and mouth. Differential air pressure on either side of the eardrum will automatically equalize. Other hazards include exposure to wind blast and extremely cold temperatures. The pilot should be aware that decompression of a small volume cabin is more hazardous than a large one. Typically, a small aircraft can be expected to decompress 10 to 200 times faster than a large aircraft. A Learjet with a cabin volume of 265 cubic feet will decompress 223 times as fast as a Boeing 747 with a cabin volume of 59,000 cubic feet. An explosive decompression, which occurs in less than half a second, is dangerous and can cause lung damage. If a decompression occurs, pilots should understand what corrective action to take. Supplemental oxygen should be used and a rapid descent should be initiated. These actions should be taken immediately to avoid the onset of hypoxia. While the high-altitude checkout may require the most extensive preparation on your part, coverage of required subject areas will benefit all pilots, not just those seeking the high-altitude endorsement. At the completion of any training program, you can point out to the pilot the importance of maintaining the newly acquired skills and knowledge. Emphasize the need for recurrent refresher training on a regular basis for maintaining the pilot's proficiency. As you can see, there are a wide variety of specialized services that you can provide to pilots. With proper planning, you can create valuable learning experiences for pilots and promote safety and proficiency. And you will have plenty to talk about when someone asks you about all the things a flight instructor does.